Chapter 6 starts off with a few definitions. The first is a parallelogram. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. We represent a figure having parallel sides with the arrows. We know that one side is parallel to the other, or its opposite, by the number of arrows on each side. So the left and right sides both have one arrow, so they're parallel, as well as the top and the bottom being parallel. A rhombus is a parallelogram with four congruent sides. So we know that our parallelogram has four sides. It's a parallelogram, hence the arrows. And the extra information is that all four sides are the same size. So we'll represent that with the red tick marks. A rectangle is a parallelogram with four right angles. So it's a parallelogram, hence the arrows once again. And we have the idea that all four angles are right angles. A square is a combination between a rhombus and a rectangle. It's a parallelogram with four congruent sides and four right angles. So there's a lot of extra information for a square. A kite is a quadrilateral with two pairs of adjacent sides congruent and no opposite sides congruent. So here's our normal looking kite. The top two sides, they are the adjacent sides that are congruent, while the two bottom sides are the adjacent sides that are congruent there. Notice I put the different amounts of tick marks on the ones that were congruent to each other. A trapezoid is a quadrilateral with exactly one pair of parallel sides. That's not the most common trapezoid. The one that most people know that a trapezoid looks like is going to be an isosceles trapezoid. An isosceles trapezoid is a trapezoid whose non-parallel sides are congruent. So it looks something like that. This drawing that you see here, or this picture, is what I call the family tree for quadrilaterals. You notice that the quadrilateral branches off three different directions. The first one is to the two pairs of parallel sides. That forms a parallelogram. Parallelogram branches off into a rectangle or a rhombus, and then those two come back together to form a square. Quadrilateral also branches off into one pair of parallel sides, which is a trapezoid and isosceles trapezoid. And then a quadrilateral also branches off to no pairs of parallel sides, which is a kite. If you ever have to name a figure by as many names as possible, start at a square and work your way up, or trapezoid, work your way up, something like that. If we need to classify a quadrilateral, in this case we're given 4 points, L, M, N, and P. We plot them on a coordinate grid, L, M, N, and P. If we connect all 4 points, that's what it will look like. What we need to first do is find out the slopes of each. To find the slopes, either you can use the formula, y2 minus y1 over x2 minus x1, or you can go ahead and just use rise over run. If we're going to find the slope of LM, you'd rise 1 and then run 2, so that's a 1 over 2. In P, we start at P though, we go up 1 to the right 2, so those two have the same slope, so those two lines are parallel. LP, it's a negative because it's falling 1 over 2, so it's a negative 1 over 2, as well as MN. So based off that information, we know that it is at least a parallelogram. On our last picture, we know that if we had a parallelogram, there's 3 different options it could be: a rectangle, a rhombus, or a square. So what we need to do is look at our angles now. For those angles to be 90 degrees, our slopes have to be negative reciprocals of each other. Since they are not, we know that those angles are not 90 degrees, so that eliminates the square or the rectangle. As for the rhombus possibility, we have to check to make sure that all the sides are the same. To do that, we have to use the distance formula. So we're going to find the distance between L and M first. Make sure that you always label your coordinates x1, y1 and x2, y2, as I've done there. Plug in everything accordingly into our distance formula. So it's going to be the square root, parentheses open, x2 minus x1, so that'd be 3 minus 1, squared, plus, parentheses open, my y2 minus my y1, which is 3 minus 2, squared. We're going to go ahead and simplify everything that we can. we end up getting that side length is square root of 5. Now, since the distance formula was done earlier this year, I'm going to go ahead and speed through this. The next points that we have to find, the next length that we have to find between 2 points is mn, which is 3, 3, and 5, 2. Plug in everything accordingly. You still get square root 5, and continue that on with the next two sides. As you can see through all this work that I've placed up on the video, you can tell that all sides are square root of 5, so that means that all sides are the same. So that means that this figure is a rhombus. Our last example, they give us a kite. They give us that the 2y plus 5 is going to be equal to the x plus 6 by the congruency marks. Since they both have two different variables, we can't solve it first. So let's focus on the 2x plus 4 equals the 3x minus 5. I'm going to subtract 2x from both sides first. Then I'm going to go ahead and add 5 to both sides. It gives me that x equals 9. Now I can go ahead and work with my 2y plus 5 equals the x plus 6. Substitute in 9 for the x. Simplify, gives you 15 on the right side. Subtract 5 and then divide by 2, you get y equals 5. Your homework is as shown.